Good morning, students. In this session, we are going to see a subject, hybrid and electric vehicle technology. From this subject, today we are going to see a topic on permanent magnet motor drive. What is meant by permanent magnet motor drive? A permanent magnet synchronous machine, which is one of the best choice for a full range of motion control applications. For example, permanent magnet synchronous machine is widely used in robotics, machine tools, actuators, and it's being considered in high power applications such as industrial drives and vehicular propulsion. It is also used for residential commercial application. The PMSM is known as for having low torque ripple and the superior dynamic performance, high efficiency and high power density. It controls with and without rotor position sensors along with the different control techniques for controlling various parameters. In this, the section 1 deals with the introduction of PMSM and how it involved and the synchronous motors. Section 2 briefly discusses about the types of PMSM, and the section 3 tells about the assumptions of PMSM for the modeling, and it derives the equivalent circuit of the PMSM. The section 4 permanent magnet synchronous motor drive system is briefly discussed with the explanation of each blockchain system, and the section 5 reveals about the control techniques of the system like scalar control, vector control, and the simulation of the system. The electric motor are electromechanical machines which are used for conversion of electrical energy into mechanical energy. The foremost, the category of AC motor are asynchronous and synchronous motors. The motors called single engine machines. There is a stator windings are connected to AC supply, whereas the rotor has no connection from the stator or to any other source of supply. The power is transferred from stator to rotor only by mutual induction. The synchronous motor require AC supply from the stator windings and the DC supply from the rotor winding. The motor speed is determined by the AC supply frequency and the number of poles of the synchronous motor, and the rotor rotates at the speed of stator revolving field at synchronous speed, which is constant. The variance in mechanical load with the machine rating will affect the motor synchronous speed. The conventional synchronous machine requires AC and DC supply, whereas it requires only AC supply for its operation. The types of PSM. There are two types. First one is a radial field and the axial field. The radial field, the flux direction is along the radius of the machine. The radial field permanent magnet motors are the most commonly used. The axial field, the flux direction is parallel to the rotor shaft. The axial field permanent magnets are presently used in variety of numerous applications because of their power density and quick acceleration. The permanent magnet can be placed in different ways on the rotor of PMSM are discussed in the figure 1 and 2 shown below. The permanent magnet is mounted on the figure of the outer periphery of rotor lamination. This type of arrangement provides the highest air gap flux density, but it has a drawback of lower structural integrity and the mechanical robustness, and the machines with the arrangement of magnets are known as surface mount machines. These are the diagram for the PMSM. It is an interior magnet. The development of this arrangement is more difficult than the surface mount or insert magnet rotors. The insert permanent magnet rotor construction has the advantage of both the surface and interior permanent magnet rotors arranged by easier construction, and the mechanical robustness, which have a ratio between the quadrant and the axis inductions respectively. The important significance of the type of the mounting the permanent magnets on the rotor is variation in direct axis and the quadrant on the both path. The quantitative axis inductance is measured by rotating the magnet from the already aligned position. In this position, the ion sees the stator flux. The flux density of the permanent magnet material is presently high, and its permeability is almost equal to that of air. And the reluctance of the direct axis is always greater than the quadrant reluctance, since the effective air gap of the direct axis is several times that of real gap looked by the quadratic axis. Thank you.